Okay, so I hope you can see the recording. Okay. Okay, is there any issue with the screen, etc.? Are you able to see the screens correctly?
I'm able to see it.
You are able to see it or unable to see it?
Able to see it.
Okay, so I think there are some people who are saying the screen is black. I request you to refresh it and check out because other people are able to see it. So yeah, so if a lot of you don't see it, then please interrupt me. Okay, so I'll repeat once again. A singly linked list is a data structure which allows us to store data such that it will have some data. Each node of it will have some data, and then it will have a next pointer which will allow you to access the next data element in that singly linked list. And typically a singly linked list is having a head pointer which will allow us to access the complete singly linked list. In general, we would like to store data which is much more complex, like a student data or some other data, but in just to illustrate it, we are going to have an integer data type that we defined. So we are going to say that the data that we have is a simple integer, and then this is the new part where we are saying that the struct node is going to have two members. One is the integer data that we are clear about. The second is a pointer. The pointer is to a struct node itself, and this is how we define this, and this is completely allowed. On the other hand, what is not allowed is that struct node will have a member which is of the type struct node. This is not something which is allowed, but it can have a pointer to itself which allows you to form this linked list. So this is what we had discussed. Are there any questions on this basic definition of the linked list? Node of a linked list? Okay, will we have today's lab on linked list? No, today's lab will be on structures. It will be not on self-referential structures. It will only ask you to work with structures, which we have seen in the Monday class and Tuesday class clearly. It may ask you to deal with pointers, but not with self-referential structures. Okay, so but tomorrow's lab will have linked list, and irrespective of whether it is graded for you or not, you must attempt these questions. They are fun. They challenge you. Again, don't worry about the grading. Don't worry about how much will it come in the quiz and so on. It's about just challenging yourself. It's like fitting these things into the puzzle and writing the correct answers. That hopefully it should be fun for you. Okay, any technical questions about the definition of a linked list? Okay, so this is how the node of a linked list looks like. That is, it has storage for an integer, it has a storage for a pointer. So when you do size of struct node, you will get something which is the size of this integer plus the size of the pointer, whatever it is, that will be the size of the struct node. There may be padding, so therefore the size may be slightly different. So you should not manually calculate it as 4 plus 8. You should leave it to the compiler to do the calculation. In this case, it may turn out to be okay. It is 12. But in general, you should not do the calculation. Leave it to the compiler and use the size of function. So one thing that can be a little irritating or can be a little tedious to write is every time you have to define the struct node, you have to use this complicated thing of struct. Sorry, you have to use this complicated name, which is this struct node. So you can use what is called as a type def. Type def is saying that I am defining this type and I'm calling this as type def. I'm saying that type def struct node. This I'm going to call as list node throughout my program. So then list node is exactly the same as struct node. Everywhere where you would have used the name struct space node, you can use list node. This is not the only thing that you can type def. You can type def anything. You can type, suppose you don't like float as the name for floating point numbers, then you may type def it as real numbers, and you can say that type def float as real. And then every time you use real as the type for a variable, it means it is actually float. So you can type def anything. This is some shortcut kind of a thing. So this you can remember. It's not something that we will use in today's lab, but today's class, but this is something that you can use to shorthand this struct node every time. Yeah, there was a question. Is there some question? I thought Kandikeshwar was speaking. Okay, so
sorry,
I
no.
assume, yes.
No, mic got unmuted. Sorry.
Okay, sorry. Okay, yeah. So okay, can you repeat the type def once again? Sure, I'll repeat that. There are some other questions that I am unable to see. Okay, can we type def struct node to node? Yes, you can type def. Oh, not to node. You have to use another name. Not to node. You have to use struct node as some other name. Okay. Will the size of the next pointer be the same as the fundamental data type pointers? Yes, it will be the same as the fundamental type pointers. I mean, it will have, okay, so you are saying what is the size of head, right? This is the question. So one of the questions is what will be the size of head? So the size of a pointer is independent of the size of what it is pointing to. That we have seen in the very few first classes of the discussion, where we said what is size of a pointer to an integer versus what is size of a pointer to a character, and that remains independent of what is the size of int versus size of char. So similarly, the size of a pointer which is pointing to a struct node will also remain independent. Okay, any other? Okay, so I'll just say this. So okay, I will repeat this thing about the type def. So this, every time I have to define this box, I have to say struct node something, right? So, or if I have to define a pointer to this, then I have to say struct node star ptr. So all throughout my program, I will have to use this repeatedly. So, okay, so I will have to use this struct node, and let's say I want to define a pointer of this type, then I have to say struct node star ptr. It means that ptr is a pointer which is pointing to struct node, which is struct node is my own user defined type. Instead, I can say, okay, let me just have a shortcut for struct node and say type def. So this is a keyword, type def is a keyword, and it will say type def struct node with some other thing that you want to call. So maybe you want to call it as a list node so that it's a shortcut for this, or you want to call it as n, capital N. That is also allowed, as long as you give anything which is a variable name, that is allowed, and you will be able to every time replace struct node with list node the way I have done this type def. And you can do this whenever you want, if you feel like doing it, and typically it is done. I'm not doing it in today's programs, but eventually you will see that that is how you will use it if you use linked list. Okay, any other questions about this?
Ma'am? Like,
Yes.
ma'am, what is the use of changing the struct node into list node, ma'am? Because it's just saying a name.
Yes, exactly. So see, every time you can avoid this word struct node every time, right? Suppose you have called this itself as struct list node. It is a big thing that you have to keep calling. Therefore, you can rename it and call it, just to say that this is a shorthand for that. That's all. So that is why I'm not going to use it in the programs, but this is something that you can be aware of. Yeah.
Okay.
Okay. So there is some other question. So in this case, to define a variable, we'll use list node in place of yes. So if you say list node x, let's after doing this, let me say that I have done for the following this thing, that is list node x. It means that this is the variable name x. X has this cell. X has two components or two members. One is for the x dot data, and x dot next is a pointer. So that is what you have defined by saying x is of this type, right? Okay, good. So everybody understands this type def. It is something which is simple. It is used extensively when you define this. That is why I wanted to mention it. It doesn't, I mean, not using it doesn't hurt us. Okay, so to go forward, what we want to do is we want to see what kind of operations we want to support on the linked list. So let's define the following operations. So let's say we have a linked list of this form. Okay, so what is the smallest linked list that you can think about? I have been drawing this picture and I am always having these nodes here. What is the smallest linked list that you can think of? Smallest in the sense, okay. Okay, so what do you mean by the head, Shashank? You have answered that it is the head. What does it mean by head? That is, you have this cell that I am highlighting and this is pointing to null. Is that what is your answer? Okay. Any other answer? So at least the 2 or 3 answers that I have got are a single node list is something that is there. Yeah. So that answer seems to be the smallest that you can think of. In fact, a linked list. So this thing, right? So let's define the following. That is, once you have defined this struct node of this type, then let me call this. I mean, let me write this struct node star head. So yeah, please excuse my writing, which comes out very badly because of the way this device is there. Let me just turn it a little bit. Okay, so so what have I done is I have said that after I have defined this node, maybe I have defined this in as a global this thing and then set struct node star head is equal to null. Now head itself is a linked list. Head itself is a linked list. In fact, it's an empty linked list. So this is the smallest linked list that we can think of. One node linked list is even bigger than the empty linked list. So this empty linked list is something that is our typically our base case or is going to be the smallest linked list that we have, and that is what we will start with, right? And then slowly build the linked list to contain so many elements. So yes, it is natural to think about a one element linked list, but there is a 0 element linked list which is of this, which is this actually, that is head is equal to null, is a null linked list or is an empty linked list. Is that clear to everybody? Okay, so this is the smallest linked list, and in fact, okay, so just to make this type definition clear, instead of writing it struct node star head, you could have written list node star head is equal to null. That is equivalent if you have written this type def struct node list node. Okay, good. So let's now go to this these operations. So the operations that we will try to write down in today's class are the following. That is, given a linked list. So let's say this is my linked list, which has 5 elements. I would like to add an element to the front. So remember, currently our data is only an integer. It can be in general a complicated structure or it contains several things. However, currently to deal with simple data items, we are going to deal with integers. So this, what it says is, let's say that there are some elements in this linked list which is here. Then I would like to add an element, but where should I add it? I will add it to front. So what does front mean? That is, this red cell that is added is the new element. Of course, this, why did it get shortened? This is not the same linked list. Assume that if you had a 4 node linked list, add to front is going to change it here. And more crucially, what it does is, why have I made this pointer red? Because it also changes the head pointer. So if you are implementing a function add to front, it will do the following. It will add this node, it will appropriately set these pointers, and it will change the head. So this is one of the tasks. This is one of the operations. The other way you can add elements to the linked list is add to back. That is add to the tail or end of the linked list. And again, I'm showing this pictorially. That is, you have an original linked list. It will get one more element added to it. The previous picture was like this, that it was having this to be null. Now it is having this pointing to the new node, and the head pointer doesn't change. But is there a case where the head pointer will change? So is there a condition under which the head pointer will change even when you are doing add to back?
Ma'am, if it's a empty node, right?
Not empty node, empty list.
Sorry,
So
empty list.
when you have the empty list and you are adding the first node, at that time the head pointer changes. All other times the head pointer remains the same. Assume that we are just doing add. So we are not making any changes to the linked list in terms of deletion at the moment. So you are keeping on adding. So except for the first time where the head pointer changes, in this case, no other time the head pointer is changing. On the other hand, every time you add an element to the linked list here, the head pointer is changing. So these are the two things that we will try to implement. The third is search an element. So for the moment, we will say, because we are adding elements in this way, that is add to front, it is very unlikely that we will have the list sorted. So this is searching an element in an unsorted list, and you will have to go through all the elements and find out the element in this linked list. And then finally, of course, whenever you are implementing a linked list, the natural thing that you would want to do is print all elements in the list. So these are the 4 operations that we will deal with. Hopefully, we'll try to finish them in today's class. At least we'll go in the other order, that is 4, 3, and then we'll go to 1 and then come to 2. Okay, good. So are there questions or comments here? Okay, so let's go to the simplest one, which is print all elements in the linked list. So what I have done is, anyway, since the exam is also coming up, maybe you are used to this kind of a model. I have written this print elements in a linked list, and I have tried to write down the prototype. So what will it take as an input? It will take a struct nodes pointer. So I've called that struct node star PTR. And then it doesn't return anything because this program itself prints this function itself prints the linked list. So it doesn't have to return anything. Before we fill in the gaps here, I would like to ask you, what will you send to this from main? So how will you call this function from main? So let's say we implement this correctly. How will you call this function from main? Yeah, I have one answer. Okay, I have two answers, but we have a large class and I hope there are enough participants. Yeah, there are more than 110 participants. So I request others to participate and tell me what do you think, how will you call this print list from main? So if something is not clear, please ask me. Okay. Good. Okay, so at least a handful of you, one handful of you, yes. So maybe a handful of you have answered. So good. So you are saying that you are going to print. You are going to call it with the head from the main, which is good. I just want to illustrate one thing here. That is. Remember, we are always saying that head is pointing to this place, right? So as long as head is pointing here, it will hopefully print out the whole list. Suppose at some point it happens that you either make your head point here, or you send a pointer to the pointer to this node, then the function doesn't know anything that you have not sent it a correct list or something. It just thinks about the list being sent as this part, and it will print out the 3 elements here which are there in this part of the linked list, and that is the linked list for it. So in fact, that is why this is a naturally recursive structure. That is, this is a linked list. I mean, the head node is a linked list. The linked list is a node followed by another linked list, right? And so on. So this is itself a node followed by another linked list, which is this. These two are two nodes which are followed by another linked list, and so on. So as long as you send the head, it is going to print out everything. If you send from here, then you can print it out from print out the linked list which is starting at the second node. So just to make sure that everybody understands, suppose I want to print out the linked list starting from the second node, what will you send from main, or how will you call it from main? So let's say the linked list does contain more than 2 elements, or maybe it contains 5 elements, and I want to print out the linked list starting at the second element all the way up to the end. So how will you call it from main? So okay, yeah. So one answer again. Okay, so in the interest of time, I will just simply say, tell the answer. So as long as you pass head pointer next, which is also of the type struct node star, that is what you should observe, that the next of anything is also of the type struct node star. Therefore, it is perfectly valid to pass head pointer next as long as head itself is not null. So if head pointer next is head is not null, then you can access head pointer next and pass it to the print node print list function, and then it is going to print out the linked list starting at this node. So I hope it is clear to everybody that you can do various things with just one print list function. So now let's complete this yeah.
And the here head which we passed in the for the parameter thing, man, is it? I mean, like, oh, is it a pointer or is it the variable which we declare for every structure? Like, is it on structure node head, or like what exactly here head means? Like, actually,
Okay, so what is head? So let's write down what is head. So yeah, so I will just write down struct node star head. So this is head. What do you mean by this? What do you mean by this? In main, you would have a space for this pointer, and it is pointing to the address of it will be represent or will be interpreted as struct node. Unless you initialize it, it is pointing to nowhere. It has a random bit pattern, but this is the cell which is given to it, and I will just say this so that it means that it is a pointer which is not pointing to anything. When you set up a linked list correctly, then you will have your head, which is, so remember, this is not the same cell of the or the node of the linked list that I am having. This is a memory cell which can hold any pointer. This could have been, you could have said int star head 2, and this same kind of diagram I will draw. Is that clear? Just because I call it head doesn't mean anything, right? I just say int star head 2. It is also a same diagram that I will draw, and it is not pointing to anywhere. So this cell that I have drawn is not the same cell that I am drawing here for the linked list. Is that clear? The memory cell which is holding a pointer, it's just holding the address of this cell if you initialize it properly. I mean, this memory, if you initialize it properly, then the memory for head will contain the address of this cell, right? Is that clear?
okay, so the head which is like which you mentioned here in the start of the linked list and the variable which you declared are not same, right?
Variable?
Like, I mean, is it structure node asterisk head, and that head and this is not same, right? No, ma'am. Like we in the main we said structure node asterisk head, ma'am.
See, okay, so this memory, right? This block, which is this cell that I have, has some address in whenever your program starts executing, right? When I say head is a pointer which is containing the address of this cell. So let's say this address was something like 1000, then the head will contain 1000. This is like 2500, then this cell is going to contain 2500. If this is 3500, this part is going to contain 3500, and so on. Does it make sense?
Yes, ma'am. So one last thing, ma'am. Like after that, we said, I mean, like head asterisk next, username, ma'am.
Head pointer next, not
Yeah,
head asterisk next. Yes, yeah.
that part alone can be explained, ma'am.
Sorry?
That part alone can be explained, ma'am.
Yes. So suppose you want to print out the linked list starting at this place. Then what do you want to give? You want to give to the print list something which is of this type, right? Struct node star. That is what you have agreed, that you will give it like that. So you want to give the address of something which is pointing to we want to give the address of a linked list, right? The first node of the linked list. Let's say you want to start your this thing here, then you are telling that let me call it with head pointer next. So if I call the function with head pointer next, then as I said here, right? So if this cell had an address of 2500, this memory cell, then I am going to have 2500 recorded here, right? And therefore head pointer next is actually will point to this place, and then you will start your linked list. So you will call it with head pointer next. That's all we said.
Okay, ma'am. Got it. Thank you.
Right? Okay, good. So yeah, so this is how we are going to do it. Now I already see the answers that people are giving to fill up that fill up this function which is trying to print the list. So okay, so how long should we print the list? As long as there are further elements, right? So as long as there are further elements, you want to keep printing the list. So the first this thing should be that as long as PTR, the node that the pointer that you are given is not equal to null, you can keep going inside the loop because there is something to print inside the linked list. So as long as PTR is not equal to null, you should go into the loop. So I hope this is okay with everybody, that we are going to go into the loop while PTR is not equal to null. Okay, so if PTR is not equal to null, only then it is valid to access PTR pointer data and PTR pointer next, right? So remember, PTR is a pointer pointing to So PTR is a pointer at the beginning pointing to the head of the linked list that is given to us. Let's say we have a 3-node linked list. This is the address of this, and you want to print the first part of it, which is the data here, right? So let's say that is something. Then we can access this as we can access this in multiple ways, but the one of the ways to access this would be to access it as PTR pointer data. There are other ways to access it. As we have said, you can also access it as star PTR. This will access your structure and then say dot data. That is also allowed, but we said that it can also be done using easier access, which is this PTR pointer data. So is everybody comfortable with this pointer arrow data? Okay,
Yes,
so yeah, okay, so if there is any question here, please ask. Okay, so the next is the remaining fill up. What is this last fill up that is remaining?
we need to update the next.
Yes, we need to update not the next, because next is not being checked. It is this PTR which is being checked. So we should update this PTR. So PTR, okay, so PTR is PTR plus 1 won't work. PTR is equal to PTR plus 1 won't work because note that this memory is not contiguous memory, unlike the memory that we have in arrays. This memory is a memory on the heap, and this could be at different locations. So therefore this is not a contiguous piece of memory. So if this cell, that is why I took examples like this cell has address 1000, this cell could have address 2500, this cell could have 3500, and so on. So you cannot do PTR is equal to PTR plus 1. Okay, so that is something that is not allowed, but many of you are correctly answering that what we should do is PTR is equal to PTR pointer next. And again, you can use the star PTR dot next notation, but that is only a different way of writing it. So this will allow you to go to the linked list all the way up to the end. When you reach the end, that is, let's go through a small example with 2 nodes. So you are first pointing, when you are passing the pointer, you are passing this address, which is the head, which is the first address of the first node. You are asking, is PTR equal to null? It is not equal to null. So while PTR is not equal to null, you are accessing PTR pointer data, or PTR arrow data, which will print this value, and then say PTR is equal to PTR pointer next. So therefore your pointer will go and sit here and it will point to this node. Then you will print the element here, and then it will go and point here, which is in fact null, and therefore you are going to stop your loop and exit this function. So this will print out the nodes of the linked list from left to right. Now one question that I have is, suppose you have sent, we all agreed that from main we are going to send it as print list head, right? So at the end of this function call that I have done, so let's say that this was how the linked list was, 3 element list, and this was head. So at the end of this function, head will be pointing here. Is that right? Because I have said PTR is equal to PTR pointer next. So after one iteration, it will go here. After the second iteration, it will go here. After the third iteration, it will go here. Is that correct? So I have lost the head pointer after I have printed the list. Is this a correct thing? So Sonish, you are saying it is it is incorrect. What is incorrect? The function is incorrect. Whatever I'm saying is incorrect. What is?
Ma'am, basically we are changing the head of the program. So basically linked list is changing. We can
Linked list is changing.
means head of the linked list is changing now, ma'am. Ma'am,
So then this.
we can write the void print list struct node of head, and we can assign head to a PTR also and change the PTR, ma'am. We are changing the head at next element of the head, I think, ma'am.
Okay, so so what I want to, so I'll repeat the question once again. The question is that if this is the function that we have written, it will correctly print the linked list. But when we call this function from main by saying print list head, this head was pointing to the starting of the linked list. At the end of this print list function, will it go and sit here? Because then we have lost the pointer to the head of the linked list, and therefore we have lost the linked list in some way. We have printed it out and then we have lost it. In fact, this does not happen, and many of you have pointed out in the chat, because it is a call by value. All things are call by value. So when you say print list head, this is the formal parameter PTR, which is the argument to this print list. In this, you are copying the address of head. So as I had given this example 1000, it is copying 1000 into this pointer, place memory cell where this place is there to hold this PTR, and it is having that 1000 copied out. So what is changing is that memory cell, not the head which is in main, because we are not accessing star head. So we are not doing anything like that. Therefore, the head in main remains intact. So intact, it doesn't change. So this is not something which is destroying the linked list or moving the head pointer at all. Even if you send it with head and do not copy it locally here, it doesn't hurt. You can simply say while PTR is not equal to null and PTR is equal to PTR pointer next. You can keep moving this PTR. This is locally changing the variable. This I am repeating again and again because you should remember what happens when you do call, when you have call by value. It doesn't change the head pointer and head pointer remains intact. So as call by value has issues like we have swap which doesn't work, it has good things also, because we could change this PTR and not get hurt by it. Okay, so any questions here? Yeah, so Satyajit, I did not get your question. Can you repeat it? It went away in the chat, I think, too far. Can you repeat your question? Okay, sorry, Satyajit, I don't know whether can't it be star or star PTR dot next is not equal to null? So why do you want this condition star PTR? Okay, so first of all, I mean the condition that Satyajit is proposing is star PTR point dot next is not equal to null. So let's first get the notation in our format. So we'll just say PTR pointer next is not equal to null. Right, so this is equivalent, right, Satyajit? This is equivalent to what you have written in this thing. So while PTR pointer next is not equal to null, do all of this. Is that what you are saying? Yeah, Satyajit, it would be helpful if you unmute yourself. Okay, so let students answer. Is this condition equivalent to the previous condition?
Now the last node won't be printed.
Yeah, so this will omit the last node from being printed, and therefore this condition is not equivalent to PTR not equal to null. So this is an incorrect condition for printing the whole linked list. If you want to skip the last element, yes, this is a correct condition. Okay, so we'll move from here and we'll try to go to the next thing that we want to do. So the next thing is the same print elements in the linked list, but we are going to write, yes.
The previous condition, like instead of PTR, you have PTR next. That can also potentially give a set fault, ma'am, if the memory is not
It can. Very good,
empty
very
list.
good. Yes, very good. It can also give, it is also incorrect in the sense that it will give a sec fault if you have a null list, because you are trying to access PTR pointer next without checking whether PTR is not equal to null. Very good. So in fact, every time that you access PTR arrow data, PTR arrow next, you must make sure that PTR is not equal to null. If PTR is equal to null, you must return or you should do something else so that you don't access PTR pointer data. Very good. So yes.
Ma'am, in that case, if it checks PTR next as null, then the previous element itself, like last button element itself, it will check now. Like, I mean, before printing the last element, last node itself, it will check if it is null and it will terminate there. Why will there be a sec fault?
So if you give a null list, what will happen? If head is null itself, then what will happen?
Okay, fine.
Is that okay?
In that case alone, yeah.
Yes, but your program should work for all cases. Even if it is a null list, this program works.
Yes, ma'am.
Right? Okay, good. Thank you for the discussion. Yeah, I'm very happy that the class is active and everybody is awake. Great. Okay, so let's look at this print list, which is the same print list, but we are going to have it in a recursive way. Then can you write it? Okay, so Shashank, I will answer. It is, even if it had null, it won't enter the loop. That is not correct, because to check whether it should enter the loop, we were checking if PTR pointer next is not equal to null. So it's already accessing that even to test the condition. So you will get a seg fault even before entering the loop. I mean, to test the condition itself. Okay, so let's try to complete this function, which is print list, which is a recursive way of printing it. And this is again very simple now that you have done it earlier. So what is the answer here? If what is the base case here? When do we not want to do anything? If PTR is equal to null, and we will remember to write null is equal to PTR so that we do not by mistake assign PTR equal to null. So this is a better way of checking null is equal to PTR. Then return. Else we know that we want to print. I was trying to write this in the red so that you can remember. So this will say PTR pointer data. See, is it writing? Yeah, PTR pointer data. And finally, what should you say here? You want to print the remaining list starting at the next pointer. So we will say PTR pointer next. And remember, again here, we are not in any difficult situation in terms of seg fault, because if it is equal to null, we have already returned. So accessing PTR pointer data or PTR pointer next is safe to do in this part of the code, which is in which you are having this PTR is not equal to null. Okay. So in fact, this can be slightly reduced, and I mean, you can say if PTR is not equal to null, then do this. Okay, so Shashank has still one more question. I'll go to the previous slide and answer it. Okay, so let me say it again. So the suggestion that one of you had was, in the while loop, say PTR pointer next is not equal to null. This is the question, right, Shashank? So instead of the condition PTR is not equal to null, this was the condition which was proposed. So suppose you send a linked list which is null, that is head itself is null. So if head is null, what will happen? You are trying to access null pointer next, and even before you check anything, you have already taken a null pointer and accessed its arrow next, which itself is an incorrect thing to do. And while checking this part, which is accessing this, you are going to get a seg fault. So if you send if you send a linked list which is null, then you are going to get a seg fault. If you send a linked list which has just one element, then it is going to take that element and say that, okay, your PTR pointer next is equal to null, therefore I am not going to do anything, so I am not going to print out. If it has two or more elements, then it will print all of them except the last one. Is this clear, Shashank? So, okay, yeah, PTR. So last line should be PTR is equal to PTR pointer next inside the while loop. It is indeed that, right, Shashank? So I don't understand. The last line is indeed PTR is equal to PTR pointer next. So is there some misunderstanding with this line? In fact, it is this PTR is equal to PTR pointer next. It is inside the loop. Okay, so in the interest of everybody's time, I'm going to move on and go to the next thing which we want to do. Yeah, so Shashank, if you still have questions, feel free to stay back after the class. I'll be happy to answer. Okay, so what I wanted to do is a simple this thing of search, and instead of going through the iterative and the recursive one, I just thought we'll write the recursive one, which is easy, and you can check out how to write the recursive one. It's not difficult. After we have written print, so the search takes two things. One is the pointer to the linked list and the key that you want to search. Again, if the PTR happens to be equal to null, equal to null, then you return -1. We are saying -1 for the key not being present and 1 for the key being present. So if PTR is equal to null, you are going to return -1. Else, what would you check here? We are returning 1 in this case. So what would you want to check here? That is, what condition should be true? Okay, so PTR pointer data is equal to key, then we will return 1. Else we want to search something else, which is, so remember, we don't have to change anything now. We have to make a recursive call. So do not say PTR is equal to PTR pointer next. That is not going to work. You want to make sure that the search list has 2 arguments. Please do not give only 1 argument, because that is incorrect even syntactically. So you are going to say PTR pointer next, comma, key, the same key you want to search, and therefore you are going to do this recursively and get the check out whether that element is present or not. So as you see, writing recursive code on linked list is a lot of fun. You can write several other things recursively on a linked list. I'm not going to spend time writing this. Okay, so although we have technically run out of time, can I take few minutes and complete the add to front? Is that okay with others? Okay, I see one yes, and just because it's very convenient to me, I'll take it up. So thank you for saying yes. Okay, so I'll remind you what we are going to do. We are going to take a linked list and add element to the front of it. So this is the picture. We are not going to this add to back. We are going to do add to front. So let's see what are the inputs to this. As usual, we have a linked list which we want to add, and maybe it is a null pointed linked list, because it is to begin with that we are adding, and of course the key that we want to add, and key in our case is integer. So these are the 2 things that we need to give to this add to front. We'll see whether it needs to return anything, and as we go along. So what does the function need to do? It needs to allocate space to store the data and the pointer, which means that we want to have this cell that we will get. So how will we get this cell and the memory? What will allow us to take this cell? What function have we seen which allocates space? Okay, new node is not something there in, new node is not there for us in C. We are still in C, even though it is almost the penultimate class. So we have malloc, which we will use appropriately to allocate this space. Then we need to set up the appropriate pointers. So this cell, which contains 2 members, which is for the integer and the pointer, we will allocate using malloc. So let's see first the code to allocate memory, right? So we'll nest it into the function properly. But let's say that temp PTR is a temporary pointer. It is defined of type struct node star. So that is correctly done. So what should be the fill-ups here so that you can correctly get a memory? Yes.
Ma'am, can you go to the previous slide 1 minute, ma'am?
Sure. Okay. Yeah. Anything that you want to ask?
Okay, ma'am, thank you. I was noting down one thing.
Okay, I will upload the notes. I feel really this thing that people do take notes, which is good, but I will upload the slides. Okay, so this temp PTR, let's say it has been appropriately defined as struct node star temp PTR. What should be this part, which remember it is the typecasting part of it, and what should be here, which is size of, what should we be taking the size of? Okay, so so please do not write the answers for everything else here. Tell me what is the answer for this first and the second with 1 and 2. People are writing it correctly, but yeah. So the first should be struct node star, because remember that temp PTR is a pointer, or temp PTR is a pointer to struct node star. So the first is struct node star. And here is where it helps to have it as a typecasted thing, so that you can say that it is type def thing, where you could have said list node star. And what should you take take this as size of? Here you should not take struct node star, because if you take struct node star, then it will only allocate space to store a pointer, not to store the node itself. So here you should have struct node. So we want space for the whole node, not struct node. So struct node star. So this is very important. This is a common mistake, that you will take space only for struct node star. The compiler won't crib. It will give you 8 bytes of memory, or how much ever is required, and that is what we will get. So this part is okay. This gives us the desired cell. We can say temp ptr pointer data is equal to key. But what should we point temp ptr pointer next? That is what will set up the appropriate pointers. So what will we point it to? Okay, so head. Where do you get this head from? The head is going to be the first parameter of our function. So therefore, we are going to get this head from the first parameter. So therefore, we need to know the appropriate this thing. That is, we need to know the prototype of the function. So let's say that the prototype of the function is struct node star ptr int key. Then this statement is the same that we have written on the previous slide. And then temp ptr pointer data is key. And temp ptr pointer next is equal to ptr. Ptr is the one that you have sent from main, which is the head of the linked list. So it may be called as head, it may be called as something, but remember that head is not a global parameter, so it is not something that is accessible. This is something that has been passed. You can call it head, no, never mind. But if you call, even if you call it ptr, that is okay, and you are assigning it to the temp ptr pointer next. So what does this do? If you are given a linked list of this form, which is so this is the linked list, which is this. Then you are given the pointer to this, which was earlier head. You are taking a new cell, which I will use with red color. This is the new cell, and you are setting temp ptr pointer next to point to this, which is this part, which is good, which you have pointed it. This head was sent as a parameter. Are we done with this? Are we done with the code? Will this set up the linked list correctly? Yes.
We should change the head to the temp ptr thing.
Correct. We should change the head, but how do we change the head? Should we say ptr is equal to temp ptr, or what should we do? How will we change the head in main? We cannot change the head in main, because main is something that, I mean, you cannot change the head in main, because main does not have an access to this temp ptr. Yeah, so all of you have understood that we haven't changed the head. That is correct. So there are multiple ways of doing this. We can pass the address of head to this and change the head, which is a correct thing to do. Or we can return temp ptr. So we will change the prototype of the function and say that instead of saying void, we are going to say struct node star, and it is returning temp ptr each time. So each time it takes the pointer to the head, it returns a pointer to a new node, and that should get assigned to head in main. So if you see this code, it is returning temp ptr, which is the important change that we have done. It is also changing the prototype of the function, which I will highlight. It is changing it, and every time that you are calling it, you are saying head is equal to add front of head I. So this is just creating a linked list with 10 nodes, which is I is equal to 1 to 10. And every time it is going to add one node to the front of the linked list. So this is one of the ways. Other people have also, you have suggested that you can also send the pointer, send the address of head, which is a correct thing to do, and then you can modify the address, modify the contents of head in the add to front. That is something that is a different way of implementing add to front. So one quick question and we'll end the class is, what will be the print list if I print it after this? I mean, after this for loop, if I say print list head, what will it print out? So just write your answers in the chat and we'll end the class here.
Can you repeat the question, ma'am?
The question is, I have all this program which I have written. I will, suppose I say print list of head, what will it print out? Remember, print list prints the linked list in from left to right order. So it won't print out only one key. So it is not the latest that you have added. That is clearly not the answer. It will print out 10 elements, assuming that all this code is correct. So the important point that I want you to notice, the answer is not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 10 to 1 because we are adding to front of the linked list. Therefore, the first element that gets added is 1. Then it is 2, 1. Then it is 3, 1. Then it is 4, not 4, 1, 4, 3, 2, 1, 5, 3, 5, 4, 3, 2, 1, and so on. And therefore, at the end of this, in which you have added 10 elements, you will have 10, 9, 8, 7 printed out. So it is not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which can be a mistake that we do, but it is add to front. Okay, so I'll stop the class here. We will meet tomorrow, which will be our last class. But before that, we will meet today in the afternoon for our lab, which is, again, I repeat, it is a graded lab. People who want to take it as a graded lab can take it for a makeup for any of the labs that they have missed or scored less. If you want to know your score in any of the labs, please ask your TA. We would have liked to send it, but as I said, there are people who have copied these, and that's very messy for me to handle. Madam, are all these in the exams? Yes, everything that we cover is going to be in the exam. Today's syllabus, there is no syllabus, but what we will have our lab is based on structures. We will not have self-referential structures in today's lab. So it will be on structures. It may involve pointers, but it will not involve self-referential structures. That is linked lists. Yeah, files for quiz 3, is it there? There may be a small question. It is more for your understanding, but there may be a very small question which I may ask, but I have not frozen this thing for quiz 3. Yeah, again, I cannot ask anything elaborately which I have not spent too much time on, but I want you to go through the video. More importantly, for understanding how do we pass parameters to main. So, I mean, again, not as a quiz question, but as something that you should understand. Yes, quiz 3 is also for 20 marks. That has been announced earlier. All the quizzes are for, I mean, we are calling it EndSem, but it is quiz 1, quiz 2, EndSem. All of them are 20 marks. That was how it was announced. Okay, so I am going to stop the recording.